All right, I guess we can start. Okay, so hi everyone. Welcome to this joint paper, selected paper presentations. So the session title is Methodological Advances in International Trade Research. We're gonna have three presenters today, Della, there is Hari and myself. So each presenter will have 15 minutes and then followed by 5 minutes of questions. Without further ado, I'll just leave the floor to Della. Okay. So just make sure you ask them if they see me.
Okay. Okay. Good afternoon, everybody, or evening, and thanks for joining my talk. My name is Stella Demdo-Fianco. I am presenting from Agroscope. So Agroscope is basically the research arm of the Swiss Federal Office for Agriculture. And the title of my talk is Distance to Destination and Export Price Variation within Agri-Food Firms. So what's the motivation of my research? This picture depicts basically what I'm trying to study. What we see here is substantial within firm variation in 4 unit values. So this is the same firm. This is one Swiss firm that produces hard cheese, and the same firm also produces semi-hard cheese. And we see that they charge different export prices to different markets for the same product. So this is 8-digit level commodity. And these are FOB prices, so transport costs are not included. Shipping costs are not included. These are free on board prices, and so technically this should be the same, right? So, but what we see is that, well, the firms are charging as high as 18 Swiss francs per kg in Korea and a low of around 12 Swiss francs per kg in Peru. And so what I'm trying to analyze, or the question I'm trying to answer here is that what drives firms to behave this way, especially when I take into account distance. So I want to see what role distance plays in this price setting behavior. So this empirical regularity, what we've seen basically in this figure, can be attributed mainly to 2 things. It could either be quality, sorting. So maybe if the distance increases, only firms that produce high quality product versions of the product, maybe they use a higher quality packaging, they then send those further away, right? So if you have a high quality version of your commodity, you are sending it further away. We could also have some alien type effect where specific tariffs, so if distance as a specific or unit trade cost would make higher quality products cheaper relative to the low quality ones if they are sold in distant markets. But it could also just be variable markup. If we have firms where trade models where firms can endogenously select quality, then they can also probably arbitrarily just change their markups across destinations. So you charge one price in Peru and you charge another price for the same commodity in Japan. But what do we do specifically in this paper? So for manufacturing firms, a lot of studies, or some studies at least, have established this export price variation across markets using firm level data. But we haven't seen enough of this at the firm level in agricultural settings, yes. But we know that agricultural and the manufacturing sectors are also characterized by different market situations. And so I think it is imperative to see if the findings from manufacturing also extend to what we see, if the findings in agriculture also extend to what is happening in manufacturing. And because a lot of the work that has been done in this regard in the agricultural sector has been focused, have used country product data, it is also not, we are not sure whether the effect is due to selection across or within firms. And so what I show with my within firm analysis, I show that Swiss agri-food exporting firms behave in a manner similar to manufacturing firms in other countries. However, as I already showed you in the slide before, this effect can be due to markups or quality. And so in a lot of the existing works, it stops there. We just say, well, we see some effect of distance, but we don't know. Maybe it is quality, maybe it is markups, or it's a combination of the two. But if we want to understand further some of the welfare effects or the gains in welfare from this empirical regularity in trade data, it may be important that we are able to separate this effect into quality and also markup. So this is also something I do here. So to preview my findings, I show that if distance doubles, the average Swiss agri-food firm increases their FOB export prices by 2.3%. And I also test my findings across different firm structures and then across the agriculture and food sectors. Finally, and where I think I make the most contribution to the literature, if I disentangle the quality and the markup mechanisms, I show that for a given product quality, exporting firms charge higher markups in distant countries. However, what I also find is that this form of price discrimination is less pronounced for higher quality products. So firms price discriminate, but they price discriminate less for higher quality products. So what sort of data do I use? I use Swiss firm level customs data from 2016 to 2020. So in this data, I can see HSA digit products. I can see the trade value, how much the firm is exporting. I can also see the volumes, how much in quantity terms they're exporting, and the country they are sending the products to in the year. And I can observe this from HS01 to HS24. And so basically, this is just how the HS-digit data structure looks like. And so we see that if we work at the 6-digit level, we may be missing out on a lot of this heterogeneity. And also, I think that at this level of data aggregation, my prices probably reflect, my FOB prices probably reflect prices. A bit of descriptives, we see that the number of Swiss firms, so in my data set, I have about 20,000 Swiss firms. The drop in 2020 is not surprising because of COVID. We also see that the average firm exports about 9 products and to about 4 different countries. We also see quite a difference between the mean and the median because not a lot of firms are exporting. So this is why the median is really, really low compared to the mean. A bit more descriptives, I also try to see the dynamics in export. And here I see that very few Swiss firms are exporting to multiple countries. And in my analysis, what I do is I only consider firms that can export to at least more than one country because it's the only way I can see whether they charge different prices in the different markets. And here we see that the model Swiss firm is serving only one market, probably Italy, Germany, or Austria. And we see a similar pattern when we also consider the number of products. According to firm size, we also see that large firms, so here I define firm size based on employment and the number of people that the firm employs. And we see that the larger the firm, the more they are also exporting. And on the right-hand side, what we see is a simple gravity relationship where a lot of firms export to richer countries. So we see here that the Swiss firms are exporting most of their products to Germany, France, Italy, the US, China, and which are a lot of rich countries. So how do I hope to identify my effect? I estimate a simple linear regression where on the left-hand side, I have unit values, which are export values divided by export quantities. I regress this on distance and a host of destination product time fixed effect, destination product time variables. And then I also control for firm product time fixed effect. And so a lot of my identification comes from the within firm variation. And then we have the error term. So to preview my results, first I start with a bit of descriptives. Here on the left-hand side, I regress HS8-digit products on distance. So these are demeaned. And then I plot the residuals. And here I see that exports to Italy. So Italy is in the dark region. This is closer. Italy is a neighbor to Switzerland. And basically what we see here is that countries that are further away, so the white bars are distance that are 4,000 kilometers away. And we see that indeed, countries that are further away from Switzerland, the distribution is skewed a lot more to the right. So export prices are higher when we go further away from Switzerland. On the right on the right-hand side, I also estimate the same regression. I take the fixed effects and I plot them against distance. So a larger fixed effect, country fixed effect here basically means that export prices to that country are higher. And I see that indeed we see a positive relationship. In terms of my empirical analysis, so my empirical analysis confirms what I see in the descriptive. So in column 1, I only regress distance, and I find a coefficient of 0.031. In column 2, I include different controls for non-tariff measures, for tastes, for GDP, which is the size of the market, GDP per capita income of the consumers in the country. And even when I control for all this, my distance effect remains the same, strong and statistically significant, which shows that when distance increases, the average Swiss firm charges higher prices to the country. I do some further analysis in a recent work by Charlotte, who's here. They show that this type of effect can be heterogeneous across the size of the exporting country. And so here I take the same idea to the firm level and see whether I find differences in the effect across firm structures. And I see that bigger firms indeed do this sort of price discrimination more. However, in the end, as I already said from the beginning, this distance effect can either be quality. So the higher prices we see here can be that the products are of a higher quality. But it could also just be that the firms charge arbitrary higher prices because they are going further away, right? And so what I want to do now is to be able to decompose this effect, so into the quality and the markup channels. In a recent contribution by Chen and Juvenal, published this year in the Journal of International Economics, they think about this in a very simple way. So if the unit values are defined as mu, which is the markup element, and marginal cost, and if we assume that the marginal cost is not varying across countries, right? So the firm has a marginal cost, and this does not vary depending on the country you're sending the product to. Then our firm product time fixed effect, if we put our firm product time effect in our models, we can identify or we can ascribe all the variations in unit values to variations in markups, right? So we see here that all the changes we are observing in unit values is due to changes in markups once we control for quality. So then it becomes important, how do you control for quality? We have a huge sample of products, and unlike wine, where we can have some aspect ratings, we have no such objective measure of quality. So what I do is I use this Candaval 2013 approach to estimate quality, which says based on, depending on prices, firms that, or products that are imported in a higher quantity are probably of a higher quality. And here I show just the relationship between unit values and this my perceived quality measure, and I see a strong positive correlation. So what I do is then I introduce this quality measure into my analysis, and I see, or we see that indeed higher quality products indeed are also sold at a higher price. So once I control for this quality, and I also have firm product time fixed effect in my analysis, I can ascribe all the variations I now see in the unit values to markups. And I also then interact the distance with the estimated product quality, and I see that the effect is negative. And so the conclusion here basically is that indeed firms are arbitrarily varying their markups across countries, right? So when depending on where they are going, they charge higher markups, but they do this depending, they do this less for products that are of a higher quality. So in the end, what I find is that if distance doubles, firms increase their FOB export prices by an average of 2.3%. And this indicates variable markups for quality differentiation. Once I control for quality, I am also able to show that indeed a lot of these variations we see are due to markup. So consistent with Chen and Juvenal, firms price discriminate less for higher quality products. So in the end, what I try to show is that sometimes some of the variations we see consumers in certain countries are paying higher prices, not necessarily because they are it is for higher quality, but because firms are indeed just arbitrarily varying or price discriminating across countries. Thank you.
So this markup, how much of it would it represent like regulations in the destination country?
Yes. So you mean it depends on regulations in the, that is true. It's also, I mean, the assumption that the marginal costs are not varying across countries indeed could vary depending on whether you have standards in the country. So if I'm exporting the product to a country that have a higher NTMs, maybe my marginal cost is different from a country where standards are weaker. At this point in time, the only thing I do is I control for standards in the importing country using this non-tariff measure, which are here defined as specific trade concerns. But I think you are right. It is possible that if I interact this also with the distance effect, I could see that it probably is also moderating the effect, but I don't do this at this point. So now I think I make a simplifying assumption that the marginal costs are constant across countries. But I think you are right that it's possible that these marginal costs are not constant. But I think we do this for simply to just simplify the identification process. No, on all products. So I only use the cheese to motivate. Yeah. Yes. Lower. Yeah. Yeah. So yes, you mean this quality ladder. What I do instead is I do this heterogeneity across. I didn't do, so to answer your question, I didn't do according to the quality ladder, but I separate the products according to the agriculture and the food sector, because indeed there should be a lot more vertical differentiation in the food sector. Interestingly, I find, and this is actually why I went further to do this analysis, I found that the effect was stronger for the agricultural sector than for the food sector. And according to, for the quality literature or the vertical differentiation literature, this is counterintuitive, because I would expect that a lot more distance effect is happening in the food sector. But since this could also be due to markups, it is possible that it is the markup components that are higher in the raw agricultural sector than in the food sector. And like Chen and Juvenal also show that the effects are less pronounced for higher quality products. This may also support my finding that indeed the distance effect is stronger in agriculture than in the food sector. All right. Thank you.
Good afternoon, everyone. I'm Hari Regmi. Today, I'm going to talk about evaluation of USDA agricultural export projection. And the co-authors of this paper are Professor Todd Keithy and Professor Ken Foster from Purdue University. So USDA baseline projection summarizes US as well as global agricultural production, demand, supply, export, import, and aggregate measure of US farm economy for the 10 years. And this long-term export projection is one of the important series of USDA export projection, which is important for business investment and long-term planning perspectives. For example, USDA 2022 report that agriculture export in 2019 supports more than 1 million full-time civilian jobs in US, and $1 of ag exports generate additional $1.14 in economy. So long-term export projection is critical in shaping US agriculture and trade policy. For example, designing effective trade policy and estimation of the farm program cost, farm bill discussion, and then presidential budget formulation as well. And long-term export projection also important in planning and decision making the investment decision. For example, it the projection is for the 10 years, and the businessman or producer or inventory to take inventory management decision. I mean, there are a couple of investment decisions that can be made based on the long-term export projection. For example, in the context of, we can talk about the climate change, what will be the trade scenario in the next 5 to 10 years, or technology adoption decisions like that. So despite the importance, agricultural export projection have not been evaluated in the literature. If you talk about the forecast evaluation literature, it's basically developed from the rational expectation hypothesis of 1961. I mean, Muth rational expectation hypothesis. Then there are series of development in the forecast evaluation literature, and those literature are primarily focused on evaluation of macroeconomic indicators, for example, inflation, GDP, or other macro indicators. If we talk about the agricultural forecast evaluation, we can see in the literature there are two strands of the literature in agricultural forecast evaluation. One is evaluating the fixed event forecast. A fixed event in the sense that there exists a terminal event, and there are a series of forecast, and forecaster can make revisions to predict, to forecast the final value. For example, you can take the USDA ERS farm income forecast, or WASD crop production, price, and yield forecast. And there is another stance of literature that evaluate the long-term agricultural product projection. It's also called the agricultural outlook. For example, USDA produces agricultural projections. Similarly, Congressional Budget Office also produces projection for different farm program cost and outlays projection. Similarly, Food and Agriculture Policy Research Institute and Food and Agriculture Organization also produces a similar set of baseline for US. I mean, FAPRI produces mostly focus on the US based, and FAO focus on the global ag productions. So, and there are a couple of studies in the literature that just began last year's. We can see that Bora et al. Study evaluate the US farm income forecast and crop production forecast, focusing on USDA and FAPRI baseline projection. And similarly, other studies evaluate the US farm income, but none of these studies evaluate agricultural export projections, despite the ag export is important in shaping US farm policy. And those studies also indicate that the baseline projections underestimate actual value. It's called a downward bias in forecast evaluation literature. That means the projection or forecast is, I mean, lower than the actual realized value. So my research question in this paper is, how accurate USDA export projection are. I measure the accuracy in terms of mean square percent error and root mean square percent error. And then our USDA export projection are unbiased. Unbiased in the sense that is there any systematic error components in the forecast, and how export projection error are related to the selected macroeconomic indicators. Then finally, I am looking on how informative USDA export projection are. I mean, informativeness means out of the 10 years, how many years into the future the US export projection have informational value. So the data set is export projection series of USDA baseline. Basically, there are 6 components in export projection series. These are livestock, there are meat or dairy product, meat and dairy products, grain and feeds, oilseed, and different horticultural products, including fruit, vegetables, cotton, and other products. So this study, I'm going to focus on 3 major categories that are bulk commodities projection, which include bulk grains, soybeans, cotton, and tobacco. High value products, these include the different processed and semi-processed commodities, horticultural products, processed animal products, sugar, and other tropical products. And the sum of high value and bulk commodity projection are total exports. So the data set consists of 24 yearly years data. Each year spans for 10 projection horizons. I compiled data set from Albert Ehrman Library at Cornell University online databases. And I compiled macroeconomic indicators from FRED database and USDA macroeconomic data sets. So this is the components of the expert projection. This is published. This was published in 2020 expert projection report. In each year, USDA produces this baseline in February, and very rarely in one cases they produces in March. Otherwise, usually they publishes in February. And these figures shows the components of the expert projection starting from 2020 to 2029. And like I said earlier, I'm focusing on the three major categories. That is the total exports, high value product exports, and bulk commodity export projections. And this plot represents the actual or realized value and projected value. So the dotted line indicates the actual or realized values, and the bold line, the bold line represents the actual or realized value, whereas the dotted line represents the projections made in each year. And these are the other components, out of this three, these are the components of expert projections. So in terms of method, I started with accuracy measures. There are two common measures of accuracy in forecast evaluation literature. One is mean absolute percent error and root mean square percent error. So here I'm comparing the USDA projection with the NIPE projection model. NIPE projection, it's also called the no change projection model that is widely used in forecast evaluation literature as a benchmarking. And NIPE, no change or NIPE projection model assumes that the projection in the remaining year is based on the actual value of the previous years. It might not be the good measure, but it's widely used in the benchmarking. And if you have not the sufficient data set to produce an alternative sophisticated time series model, it gives a good indications for the comparison purpose. So mean absolute percent error is not sensitive to outliers, whereas root mean square percent error is sensitive to outliers, and if there is any outliers in the data sets. Then I test for the unbiasedness, and based on the rational expectation hypothesis, our forecast is optimal forecast should be unbiased and efficient. Unbiased means there is no any systematic error. Efficient means forecaster use all the available information available during the forecast. Available at the time of forecast. So I use the Holden and Peel test, in which forecast error is regressed on some unknown constant, and I set the restriction for the alpha. If alpha is different than 0, the forecast is considered not optimal. A positive alpha suggests under bias, that is under downward bias, that is under prediction, and negative alpha suggests over predictions. And then after the test of informativeness, I follow the Bretting and Neupel approach. And this approach tells us that out of the 10 years or any, the forecast have more than 10 years horizon or less than, it's called the path forecast in forecast evaluation literature. And in our case, out of the 10 years, how many years into the future the projection have some informational value. So according to, the authors propose two hypotheses. That is, one is called no information hypothesis, which indicates that the projection or forecast have information under the given information set. The forecast has information value if the mean square percent error of the forecast is lower than the variance of the realized value. And the author shows that if the projection is identical to the conditional mean of the projection series, it's called a constant mean hypothesis. It is less restrictive than no information hypothesis. So both hypotheses can be tested in Mincer and Jarno's regression framework. It is a standard regression in forecast evaluation literature. No information hypothesis is equivalent to testing. The coefficient in Mincer and Jarno's regression is less than 0.5, whereas constant mean hypothesis is equivalent to testing. The coefficient of Mincer and Jarno's regression is less than or equal to 0. And we compute the maximum informative projection horizon by subtracting 1 from the smallest horizon, for which for the first time you fail to reject the null hypothesis. So this is the result. I just want to highlight two things in this graph. This is a measure of accuracy. First, if you can see from left to right, if you increase from horizon 0 to horizon 9, the error increases. That means the accuracy of the projection rate decreases as you move further out. And another is, if you see the NIPE projection model and USDA projection model, USDA projection, the error is lower for the USDA projection. USDA projection is represented by triangle, and so we can see that USDA projection are at least as good as NIPE projection model. And this is the similar, follow the similar trend for all the components of the expert projections. And this is the estimate of the test of bias. And here is, I'm going to highlight two things. One is, if you see from the table that there is no, or almost a few stars on the left panel of the table, and whereas you can see more stars on the right panel of the table. That means the projection are biased for the longer projection horizon. That is, there is some systematic error components in the projection, whereas the shorter projection horizon are unbiased. And this is just a summary of this table. We can see that total export, high value products, and bulk commodity projection are basically unbiased from shorter projection horizon and biased for the longer projection horizon. And then I try to see whether there is any economic factors that explains the bias of these USD export projections. Then I regress the export projection either with selected macroeconomic indicator based on literature, and I found that except the foreign GDP growth rate, all other macroeconomic indicators influence high value products projections, whereas I do not find any statistical significant relationship with bulk commodities. That means, for the total exports, I only found the total export projection error is increases with increasing crude oil price. Then finally, I estimate the test of informativeness. That means information value of the projections. So as opposite to the bias, you can see here that on the left panel of the table, there are more stars. That means our null hypothesis is the projection do not have information value. If you reject the null, that means the projection have informational value, but we didn't see any stars on the right hand side. That means USDA projection have informational value for shorter projection horizon relative to the longer projection horizon. I just summarized this giant table here, and we can see that under the no information hypothesis, that is more conservative than the constant mean hypothesis, the total export and bulk commodity projection are informative up to 4 years, whereas high value products are informative up to 3 years. The one potential reason might be bulk commodity includes the large share of soybeans, and the import of the soybean is relatively predictable. For example, China, China is the largest importer of the soybean in case of the US. And high value product commodity includes processed and semi-processed products, and the importers of the or consumers of the high value products are relatively more likely to substitute products from other exporters in global market. So finally, in the conclusions, USD projections outperform the NIPE projection model. And in general, USD export projections are unbiased for short projection horizon and exhibit downward bias, that is under predict for the longer projection horizon. And this is kind of what I find this finding is similar to the existing literature. Many existing literature, including the farm income forecast and other WASDE forecast, indicate that USDA projection under predict realized values. So compared to the high value products, bulk commodity projection error are less sensitive to selected macroeconomic indicators. And total export projection and bulk commodity projection are informative up to 4 years into the future, whereas high value products are informative up to the 3 years, and the result vary on the constant mean hypothesis, which is relatively less restrictive than the no information hypothesis. Overall, we can say that USD export projection are good. It has informational value. Thank you. If you have any questions, I'm happy to answer. Sure.
So in this case, there is some bias.
Yes.
So how do you think
Yeah, that's a good point. There is one literature that published in AAEA last year. From Sid Bora, that is from the Ohio State University. There might be other economic factor as well, like we see here in the, if you see the unbiased, but some economic factor, let's say, for example, oil price can contribute to the this bias. But Generally, forecaster, like say government forecast, have some reputational purpose, and due to the asymmetric loss function, they are usually kind of under predict the realized value. I mean, it depends on what kind of projection or what kind of forecast you made. So the assumption of the loss function might be on potential reasons. I mean, basically the government agency, for example, USDA, may concern for the reputational issue. I mean, or they usually kind of, most of the literature indicates that they produce underestimate the realized value. That means there is some bias. And potentially, we can explore some economic factors. Let's say, for example, exchange rate or commodity trade exchange, weighted exchange rate, or our bank prime rate might be contributing to that bias. And then the forecaster, for example, USDA should include these economic factors to make these projections. Sorry. Okay.
All right. Hi, everyone. My name is Carlos. I'll be presenting my paper titled, "Is the Gravity Model a Power Law? Evidence from Colombia." So this research was founded by a USDA NIFA grant, and I'm very happy to present this paper to all of you. So just before I start, when I refer to the gravity model I'm referring to the gravity model of international trade, right? And I'm basically interested on the effect of distance on the amount of trade between countries, right? So there is the idea that if I increase the distance between two countries, the trade between them will reduce. Okay. So before I start, some motivation for the paper. Let me just put this so that people can see it. Great. Okay, so conventional gravity models, they explain the distance elasticity of trade in the same way, okay? So it's the product of iceberg trade costs, this notion that I lose part of my shipment as I send the product abroad, times the elasticity of trade to trade costs, right? So that's the conventional way that we think of the distance elasticity, and it has been used at least since the 1980s, okay? However, there is a criticism provided by Cheney in 2018, and he says that, okay, the product of these two parameters is providing the most conventional distance elasticity of trade, which is 1, which means that if I double the distance between two countries, the trade between them will halve, okay? And that prediction has been stable over time and space, despite large changes in technology, policies, the type of products exported, the type of transportation means. So based on that criticism, Cheney proposes a new model where the distance elasticity of trade is a power law, okay? And it just arises from two growth processes. There is an implied growth processes in firm sizes. So firm sizes is just the measure of the firm's total export sales. And there is a growth process within the firm of the export distance. So as the firm becomes larger, the average export distance measured in kilometers will increase, all right? So this new model is appealing because it does not require assumptions of the functional representation of trade costs at the firm level. So there's no iceberg trade costs. We forget about this elasticity of trade. There is some elasticity, but they have other theoretical background. So the research question, well, basically it's derived from the fact that the Cheney model works well in French data. Cheney tests this model in French data in 1992. So the question now is, would this model work in data on a less conducive environment such as Colombia, right? So Colombia has a lot of issues. I mean, it had some export restrictions in the 1990s. It's surrounded by neighbors that are difficult to access, such as Brazil, Panama, and some of the neighbors are low-income countries, or they have political issues, such as Venezuela. So this new model brings an alternative way to think about the gravity model. So the question is it applicable to other samples? If it does not fit for those samples, where does it fail, or how does it fail? And then I try to answer, what are the smallest changes I can make to the data to make the model fit? Okay, so that's going to be my final goal. So this is just a brief introduction of the new model proposed by Genet. It's just summarized into this proposition 1 of his paper. And he says that if the following conditions hold, okay, he just needs that there is for firm sizes to follow a Pareto distribution with a given parameter, lambda. He also needs that the average square distance of exports to be a power function of export sales, meaning that as firms get larger, they export to longer distances, and this also has a shape parameter. The third one is just a parameter restriction. And if that holds, the distance elasticity of trade converges to a constant given by this formula, right? It's 1 + 2 times lambda - 1 over mu, okay? It's given by the shape parameters of the other two distributions. So as you see, this result does not require any CGE framework, no structure on the firm, no structure for consumers. It's just probability distributions. And he incorporates some Bayesian thinking in a sense. So the most common value for the distance elasticity, as I said, is 1. So under Zipf's law, where the shape parameter of the firm size distribution is close to 1, you will obtain the distance elasticity of 1. This is the most common value across samples. However, if there are deviations from that, I will show you that probably that provides some issues. So even though this paper, when you read it, there is a lot of math and so on and so forth, but the intuition is very simple, okay? It's basically saying that if the effect of distance on trade is going to be stronger if there are more smaller firms relative to large ones. Why? Because if we have the notion that larger firms export to longer distances, so if in a country there are a lot of small firms, then probably there's going to be more friction of distance on aggregate trade. And this is given by the parameter lambda. And this effective distance on trade is going to be milder if distance rises faster with firm size. So if a firm, for instance, exports 1 million in the first year, and then in the second year exports 2 million, and the average distance that it exports to increases, then that effect is going to be smaller on aggregate. So the micro foundations for this result, Genet proposes one model, but any process that sufficiently ties growth in a firm, growth of firm sales to growth of the geographic scope of sales for that firm will be able to explain these results, okay? Genet proposes a network model that I have left it explained in the paper. So I'm just going to jump into the data. The data that I use is firm level export data from Colombia in 2018. I focus on differentiated goods using the Rausch classification. So these are goods that they have a lot of heterogeneity between them. And why do I use them? Because if I want to compare it to the results obtained from France, France is mostly a manufacturer of differentiated goods, such as maybe electronics or more manufactured goods compared to Colombia, who exports coffee, flowers, and so on and so forth. So just to make that comparison a bit easier. I also restrict to firms that exports more than $200,000. And why do I do this? Well, because we have a Pareto distribution. So in the literature, when I try to estimate that probability distribution, we try to focus on the right tail of the distribution. And this is the most common cutoff, 200,000. And that leaves me with approximately 2,000 firms, and I place them in bins according to their size. Aggregate exports to foreign markets are matched to distances from CEPI and bilateral trades from flows from BASI, and these are just used for the gravity regressions. So I'm first going to show you some graphs comparing the behavior of the Colombian data and the French data. So these are conditions 1 and 2. In the left panel, there is the results for condition 1. The x-axis is just firm size, and the y-axis is the counter cumulative distribution. So 1 minus the CDF. So the left panel, what it will show us is that French firms are larger than Colombian firms, right? So I made some adjustments to make this comparison using inflation, exchange rates, and so on. And we see that actually French firms are larger than Colombian firms. And when we see for condition 2, here I just changed the y-axis to the average export distance. We see that actually Colombian firms are exporting to longer distances than French firms. And why does this happen? Well, because as I said, the neighbors around Colombia are very small countries. And actually the most natural market is going to be the US, which is further away. So they prefer to reach that destination first. We also see that firms in Colombia, they follow the export distance that they have increases up to a certain point, okay? And after that, larger firms will start exporting less, or they focus on smaller markets. So let me just go briefly through the results. Top panel is Colombia, lower panel is France. The shape parameter of the Pareto distribution is smaller in Colombia, which basically means that there are more larger firms relative to small ones in Colombia. Then when I calculate the parameter for condition 2 in proposition 1, I have that export distance grows faster in France compared to Colombia. And now what happens is that when we apply the model in Colombia, we see that the predicted distance elasticity actually has the wrong sign. So it's minus 1.9 in Colombia, and is not close to the one observed in the data. However, given that there is a large standard error, when I do a chi-squared test, the test does not reject the null hypothesis that there is a difference between the two results. And also we see that the distance elasticity in Colombia is almost 3. So that's 3 times the most common observed value. Okay. So then I apply a maximum entropy problem where the goal is to find a set of small changes to make the Colombian data fit the model. Okay. I carry out 4 exercises, but here I just show the results of the first one. What I try to do is I reallocate trade across firms and export destinations to make the model fit. So these are the results where I compare the solution from the maximum entropy problem to the original data, conditions 1 and 2. And basically what we observe in the left panel is that to make the model fit, I have to reallocate trade from the largest firms to the smallest ones. And also from the right panel, I need for the largest firms to export to longer distances, right? So that's basically the adjustment that I could make in order to make for the model to fit. Just parameter component estimations in the ME results, the value of lambda is larger, the value of mu is larger compared to the original data. And this is what is perhaps the most surprising. I didn't put any restriction on the distance elasticity. I just need the model to fit. And what I obtain is that once the conditions are met, you get a distance elasticity that is close to 3, and that's actually close to the original Colombian data, okay? So the conclusions, first, the specific functional predictions of the Chenet model fail in Colombia. And an optimization problem shows that a set of small departures from the Colombian data, it shows what I can change to make the model hold. Okay, and basically what I need is to reallocate exports from the largest firms to the smallest firms, and the largest firms have to reallocate exports to more distant destinations. However, these changes are unlikely to occur in reality. Why? Because many of the largest exporting firms in Colombia, they are branches of foreign multinationals, all right? So there is a big car manufacturer from France. It has its office in Colombia. And basically that office, what it does is that it provides these cars just to South America and the Caribbean. So really, there is no motivation there to export to other countries that are further away, because probably that multinational has another office that can do that. There are also big cooperatives that they gather data from small producers. So basically, that's another issue that for this not to occur. So yeah, that's it. So if you have any questions, I'll be happy to answer. Thank you. Yep.
I was wondering if the results are related with the highly concentrated export out of Colombia. I mean, oil, for instance, or coffee, everything that say 40%.
Yeah.
So I was wondering if that is related with what we're finding. And I know if France has also great concentration or it's different and always affecting that.
It should be affecting for certain. I don't have, I took out oil exports from the data, but I do have, I think, some derivatives from oil. I think, yeah, but they should drive the results. But I think the idea is to, in the future, provide some adjustments to the model so that it could work in Colombia, even given those differences. I don't know if that makes a lot of sense, but yeah. Okay. Yep. Yeah. So when that happens, no, they're worse actually. So when I apply those results, this shape parameter, lambda, is going to be much smaller in Colombia. So it's like 0.5 or 0.6. So, yep. Yep.
I was wondering about the last thing about that is very likely that happens.
Yeah.
I was just thinking about the case where Venezuela, for example, like a region of whatever. Wouldn't that maybe do that? Like the smokers might go to the party there, and then because there's like more development around, and maybe the big they will be further away than the US.
It could, but the thing is that Venezuela is just one data point in the gravity regression. That's the one thing. And then the other thing is that we're going to need more countries to do that around Colombia. So France basically it has all these big neighbors all around them. It has Germany, Belgium, Luxembourg, Liechtenstein, Spain, Portugal. So it's really easy for them to have like many destinations all around them. But I think in the case of Colombia, even if I include Venezuela, like it's going to be like 2 or 3 countries where I have that concentration. But yeah, yes. No, I think we should adjust the model probably by adding a 4th condition. The thing is why I didn't do that when I started this research project is that that's a very ambitious endeavor in a sense, because the model uses a lot of math that it will require more time to finish within 5 years. But yeah, I guess probably the future would be to include a 4th condition. What I thought initially was to take into account the initial size of the firms that export, right? So perhaps, well, what happens in Colombia at least is that in the first year, you have a lot of heterogeneity of firms. So they could be like small firms or very large firms. And a lot of those firms, they disappear within the first year of exports. So I guess probably if you take that into account, the model could be fixed. Yep. Yep. Yeah. Yes. The two things. No, it's both. So I think that's explained a little bit better with this graph. So you see here that first the slope of the shape parameter in the Colombian data, it's smaller than what it should be according to the model. But then when I also do condition 2, we see that all those large firms, they're not exporting to long distances. Yep. Okay. Any other questions? No. All right. Well, thanks a lot.